In these examples, I'm going to show you how to solve quadratic equations by taking square roots. So the directions say to find the solutions. So whenever you want to solve quadratic equations by taking square roots, I would use that method only if your quadratic equation is in vertex form. If on one side of the equation we have the quadratic in vertex form. So that way you can easily take the square roots at the end. So like this one, our goal is to isolate the x. So all I'm going to do is I'm going to use inverse operations. So opposite of subtracting is adding. So I get x squared equals 25. And the opposite of squaring the variable would be taking the square root. So you take the square root on both sides, put the big plus or minus. So my answer would be x equals. Common mistake students do is they write the 25 again. Or what they do is they write the square root of 5. But keep in mind that you already took the square root. So your answer is just plus or minus 5. So those are your solutions for that equation. In the second example, now this is a little more complex. We're still using inverse operations. So we're going to work from our way from the outside to the inside. So start with whatever's outside of the x and then build your way inside to where the x is at. So let's use inverse operations. We're going to send the 2 to the other side by subtracting 2 on both sides. And I bring down this whole term. 4 times x minus 4 squared equals 16. And then I'm not done. I cannot take the square root yet because we need to build our way from outward inward. So I'm going to divide both sides by 4 because 4 is being multiplied to x minus 4 squared. I'm doing inverse operations. I'm dividing both sides by 4. So in here, x minus 4 squared equals 4. And now to get rid of the power of 2, I'm going to take the square root of both sides, put a big old plus or minus. So on this side, I get plus or minus 2. This side, I get x minus 4. And now I need to solve for x. So I isolate the x. So I'm going to add 4 on both sides. Because adding 4 is the inverse operation of subtracting 4. That cancels out. So x equals 4 plus or minus 2. So I have two cases now. One case, x equals 4 plus 2. So one solution is x equals 6. The other solution is x equals 4 minus 2. So x equals 2 would be the second solution to the second example. Or in this case, or on the first example, if you want to split it up as x equals 5 or x equals minus 5. Those are the solutions there. Example 3 is a little bit different. That is because now that we're doing inverse operations and we're subtracting 16 on both sides, we get negative 16 on one side of the equation right before taking the square root. But what happens is when I take the square root, I'm going to get an imaginary solution because I have a negative inside the square root. So this side, the square root of 16 is 4, but because we have a negative inside the square root, I need to pull out the letter I. And then I bring down the x plus 3. And I do not forget my plus or minus. Then I subtract 3 on both sides. So x equals negative 3 plus or minus 4i. So in here I have two imaginary solutions. X equals negative 3 plus 4i. Or x equals negative 3 minus 4i. And there. All done. Sometimes some textbooks will tell you that you're okay saying that because you can't take the square root of a negative, that you can say you just have no real solutions. But in our class we learned how to find imaginary solutions, so I would list the imaginary solutions.